Hello everyone, my name is Michal and today we will be looking at automated engineering. And while, I know this is a visualization week, the automated visualization creation is just a small break in the automated engineering wall. For this reason, today we are going to cover TIA Openness as the TIA Portal API, SiVarc Semantic Visualization Architect, and the TIA add-ins, which allow you to put some extra functionality into TIA Portal itself. Normally, I would start my tech talk with some theory, with an explanation of the products involved, maybe a few slides, and then show you a live demo. That's how I normally roll. This time, we are going to flip the order. So, let me start by showing you the art of what's possible. So, a sample application that utilizes the aforementioned technologies, the briefly aforementioned technologies. So, TIA Openness and SiVarc to generate a project from scratch based on some user choices. This way, when we go back to specific technologies used, you will already have a vision in your mind, showing you how it could be applied and maybe what could actually be done with these technologies, what is possible. Okay, so let me close this. Just one slide for you today, or now, and let me fire up this. So, what I have here is a simple sample program written by my colleague in C# with Visual Studio. But as we don't want to go through technology itself yet, let's just focus on the GUI, not the actual project running behind the scenes, not what's under the bonnet. But please remember, this thing here is just a sample. It's something that we have done that you could do as well. This is not TIA Openness. This is not SiVarc. This is just our little demo showing you how these technologies can be used to, for example, automate the creation of a modular machine project. And this is just one of many, many use cases that we have identified, our customers have identified, and I'm sure that you can think of some that we haven't. So before we start with this, just to give you maybe some context, let's assume for a moment that I'm not Siemens, I'm an OEM. We, so the OEM, make these modular machines that, depending on the end customer requirements, might need different size of the PLC, different number of drives. Maybe a small machine has a single conveyor driven by a G120C, but the bigger machine can have 7 of them. Also, the lower end options, for example, might not have a HMI, while the bigger ones do. And this is the information we will put into the first step. So we need a project name. Let me just delete these guys first. So the project name is going to be tech dogs. PLC type. As this is our medium machine, let's say, we will be using 1516. We will be using our G120C drives that are our standard general purpose drives with Profinet, with SD on board, and so on. Now we have some decisions, so checkboxes. Do we want to also generate the HMI project? Well, since it's visualization week, the answer is going to be yes. And we will also want to use SiVarc Rules. So SiVarc will allow us to dynamically generate some things as well. Again, how many drives do we want? Medium machine, 3 drives. Cool. So now we can define few things around our CPU, the S7-1516 that we selected in the previous step. So things like name of the CPU. My CPU, and I know it's not very creative, but this is just a demo, just a sample. Now 2 tick boxes. So going back to the story about me being an OEM, let's say that us as an OEM, we have identified that our customers they quite often want to integrate our machines with some other machines, so they need machine-to-machine communication. Or even, let's adjust this story. Let's say that we as the OEM, we make packaging machines, and lots of our customers use PackML. So that's a companion specification for OPC UA. For this, then, we will need an OPC UA server on the POC. So if the customer decides to pay for this functionality, there you go. We can put a tick box for OPC UA server. And just as a side note here, if OPC UA server is of interest to you, if these technologies are of interest, I believe it was Dave Walker with Andy Williams. They already had a tech talk on communication technologies some time ago. They also covered OPC UA, and this tech talk is available on demand. So if you just go onto our website where all the tech talks are, you can watch it whenever you have some time. But going back to this project, we have another tick box. So our recommendation is to enable the web server whenever we can. And we, again, as the OEM, we decided we will sell this web server as an extra functionality to our end customers. They can use the web server for diagnostics or even for integration with IT systems using the new web interface, the JSON RPC. We also maybe include some custom HTML pages because you can add them to web server. That gives our customers, I don't know, an overview of operations maybe with some KPIs, with some statistics. Anything you want can be on the HTML custom web page. So again, if the customer decided that with this machine that we make for them, they want the web server, we have another tick box ticked. Yeah. So now some extra data. We decided that our machine will have 3 drives. So here we can select the names for the 3 drives. And again, conveyor belt 1, conveyor belt 2, and as you have guessed, conveyor belt 3. So that's all the configuration that we can put here. And again, this is our sample demo. Maybe if you like Openness, maybe you will create a program like this yourselves, and maybe it will be 3 times bigger, have more tick boxes, and whenever the end customer approaches you, you will just go through this, tick all the million tick boxes you have, press generate, and it will just throw it to you ready to use project. With this simple demo, we decided that's okay. So we click generate. What is going to happen now, the program will launch us a new instance of TIA portal. It will start it with the GUI, so with the user interface. But it's also possible to have it running headless, so without any visible output if we want it. So if you wanted to create a project that maybe just creates your TIA project and just saves it on the desktop, or maybe uploads something from a POC, saves it on the desktop, but in a way that the user, the person who's actually using your program, doesn't even get to see TIA. Well, this is possible as well. So the reason why nothing is happening currently is because under this there's a window, and TIA portal now asks us, or asks me, to give the program a permission to execute Openness commands to actually use the Openness API. This thing here is the firewall, if you will, inbuilt in TIA portal, preventing other applications from executing malicious code, from using the API, and from doing things that might affect our projects. So we need to click yes consciously, to grant access and actually allow our application to make some changes to the project to drive TIA. So we click yes. So you can now see a new project called Tech Talks is created in Tech Talks folder on my desktop. Now the program will start executing various commands. We start bringing libraries. I start copying them to project libraries. It will bring the TP900 comfort panel, which is our standard panel that we use in any of our projects, we as the OEM. Next, it will drop us an S71516, hopefully with the name that we have selected. it will bring, what do we do, 3 drives with correct names. In the POC, we should also have some goodies like the technology objects to control each of the drives. We should have some program code. All the drives will be connected, and so on and so on. Nice thing is all this is done automatically without any user action required. You know, I could just go back to the kitchen, make myself a coffee, and leave you looking at this. But don't worry, I will just talk you through what's happening. So it could all be done automatically with me just, typing the information here, clicking generate, and then waiting for this to be finished. This means that any unskilled person can fill these few boxes based maybe on the customer order, and in a couple of minutes create a project that will act as a base for further project development, which is, I think, pretty amazing. Because if you think about bigger projects, you would need to drag and drop your PLC, you would need to drag and drop all your drives, drag and drop the HMIs, interconnect everything, and these things, they're not necessarily complicated, but they still take time. These are actions that you need to do all over again. Just drag and drop one drive, second drive, third drive. Maybe you have 40 drives, so keep dragging and dropping them, keep connecting, giving them names, setting IPs, and so on and so on. So if something can do it for you, I think that's perfect. So automatic generation completed. And now if we look into, sorry, my mouse. Now if we look into the POC, if we look into program blocks of our POC, we can see that multiple blocks were added, and mainly for our drives control. If we open the OB1, we should find that a drives function block is executed here, and inside the drives function block we should have further blocks, and you won't guess it, but there are 3 blocks, 1 block per drive with the correct technology object interconnected. Yeah, so 3 different TOs interconnected, because it also added us the technology object. So we already have 3 TOs, 1 per drive again, speed axes, pre-configured, ready to use, already in the project. These are connected to our blocks. If we go into the blocks themselves, they call further blocks. 1 block controls the axis to which the block is connected, so the TO to which it is connected to, and the other block receives and exchanges data with the HMI. So actually allows our faceplate from the HMI to drive the drive, to control the drive. Talking about the commands, one thing we do need to do manually is we need to create an integrated connection between the HMI and the PLC. So there is a connection, but we need an integrated HMI connection. Yeah? Okay, so we have, what do we have now? Let's go back. So we have a program PLC. We have TOs, technology objects, speed axes, to control the drives. We have the drives configured, connected via Profinet with the blocks to control them. And if we go into the drives config, into properties, we open Profinet interface, Telegram config, you can see that each and every of these drives, has Telegram, standard Telegram 1 configured, so it is already ready for speed control. But we also wanted some functionality enabled, didn't we? We said that we want a web server, we said that we want OPC UA, so let's check if these are enabled for us. So we go to the PLC, we go properties, OPC UA for us, why not? We scroll down, there you go. OPC UA is active in the properties, and if you scroll down, where is it? Oh, also here, the standard SIMATIC server interface is active, which means that if I now downloaded this project, use something like UA Expert, I should be able to access the data via OPC UA. The other thing we wanted was the web server. So if I click on the web server, again, web server is activated on this module, access only via HTTPS enabled, and this is what we would recommend, access only with HTTPS. You remember I briefly mentioned that there is now an option to integrate your PLC into IT systems by using this new web interface with JSON RPC. If you look at our previous tech talks, I'm pretty sure that we already talked about this. Well, it was actually me who talked about this when I was talking about the future communication protocols. And then I showed a demo on how you can write, again, another program to connect and send JSON RPC commands to extract some data from your PLC using this new web interface. But what it needs a HTTPS connection. So it can't be HTTP, it needs TLS encryption for security of the data transfer. So that's all good. That's all ready for us. So the things that we wanted seem to be set and seem to be configured. So yeah, that's it. The PLC is ready to use. That's all we wanted on the PLC end. Also, the PLC got compiled for us without errors as the last step. As you can see, compiling finished, 0 errors, 5 warnings. So as the last step of the project creation, we also decided, because it was a decision in the program itself, that we want the PLC to get compiled. Yeah, so that's the PLC. What about the visualization? So if you go to the operator interface, we have our TP900 comfort panel here. Let's check it. Let's open the screens. As you can see, we have some predefined screens. These screens are the library screens. So I hope you all know the HMI design template. If not, again, I believe James Cotto had a tech talk on HMIs, and he mentioned, I'm sure he mentioned HMI design template. So that's something that you can download directly from our support site and use it in your project. So that's just a library that's containing these templates. So they will drop automatically onto the PLC, onto the HMI. But what we also have is this drive screen, which, as you can see here, is a little icon saying SIV next to it. That's a SiVarc screen. But it's currently empty. It's empty because we now need to execute the SiVarc rules. So if you remember our program, the tool that we used, there was a tick box asking us, do we want to generate SiVarc rules? If we said no, it wouldn't generate them. If we said yes, it generated them. So now we can use SiVarc rules to dynamically generate some extra screen objects which will be connected to data on our PLC. And this may sound confusing, but when I actually do it, it's going to make much more sense what actually happened. So to do this, we need to right-click the HMI, generate the visualization, and then I need to select the station, because the rules could be applied to different PLCs, and what it does, it just looks at the rules, looks at the objects in the PLCs, and based on the objects on the PLCs, it creates some objects on the HMIs. Again, confusing, or at least I'm not very good at explaining this, but we just select our PLC, we say yeah, all rules, and we can now start generating visualization. Now, depending on the complexity of the screens of the objects, it can take longer, it can take, well, it doesn't take long, does it? But if you go back to screens, you can see here, we actually have 2 screens called drives. Why? What happened? Well, we selected 3 drives, and only 2 drives faceplates can fit on a single screen, as you can see. So what SiVarc did, automatically, it added another screen for us to fit the 3rd faceplate for the 3rd drive. So, if you had 1 or 2 drives, you would have only 1 drive screen. If you had 3, 4, 2 drive screens, 5, 6, well, 3 drive screens, as you can imagine, and so on and so on. So SiVarc can just handle it for you automatically. Just say, I want, the faceplate to be put on this screen, in here, and if there is more, just create me more screens. That's it. What about these faceplates? They are actually quite good, because if you look at properties and you open up the interface of the faceplate, what you can see here is that they are fully connected to the corresponding technology objects. So they are already tagged up to our drives. They're tagged up, to our PLC code. If we go to the tag table, you can find them here. They're already connected to the CPUs and to the PLC tags. So this is all fully linked. And, well, since they are connected to the corresponding TOs, to the corresponding technology objects, no further action will be required here. And this project could actually be used as it is or manual control of these 3 drives. And while this wouldn't probably be the end of this story, and further development would be needed, use of automated engineering tools like Openness, like SiVarc, can really speed up project development by allowing anyone to just quickly create these sorts of project templates that will then be, they will be customized based on specific project requirements. All this to speed up the development, to mitigate the risks by reusing tested and proven code and just decreasing the time to market. So, as I said, there's only one of use cases we have identified. Other thing could, for example, be a service tool. That is a little exe file that a service engineer could run to automatically extract the project from the machine, save it on the desktop, generate a list of differences between this project running on the machine and the one that the machine was loaded with. All this without even showing the service guy TIA screen at all. It could all do this headless, and then they can take further actions with it when they have the list. They can see, okay, these things change, Mr. End Customer. What have you done? This is why it's not working. It wouldn't even have to be a service engineer, would it? Like, you wouldn't need to be a skilled engineer to run a program like this. A program like this could be even running on the network automatically, just monitoring the projects, around the factory, making sure that there are no changes introduced. Or if let's say it runs daily or it runs weekly, grabs the projects from the PLC across the factory floor, and if it sees that there is a difference between the project that it has and the project it had last week, it could automatically record this information, it could automatically generate a list of differences and maybe notify someone. Maybe, the end customer could have a program like this, and when they have a problem, they could just run it to upload the project, maybe also dump the diagnostic buffer and send it to the OEM. Maybe automatically, maybe just a button on your unified screen to do all this, and send it to the OEM or the third party who they have a service contract. So possibilities here are really, really endless. Yeah, if you can do something in TIA, there is a huge chance that you can do exactly the same thing directly from the Openness API. So what gives us these possibilities? Well, the heart of automated engineering says, as you can imagine, TIA portal openness. But what actually is openness? Well, if you just wanted to find the answer, the easiest way to do it would be to just go on Google, go on our support site, and there, Google TIA openness. I hope. So there you go. There's actually an application example, TIA portal openness, with introduction and with demo application. And it will tell you that TIA portal openness is the API interface for both WinCC and Step 7 in the TIA portal. It enables TIA to be integrated into your own development environment to automate the engineering tasks. You can use external development environments to create your own applications. So you can make code generators for HMI images and PLC software blocks. So that's exactly what you've seen. And it came with V13 SP1 onward. But as I mentioned already, it is heavily developed. Like with V16, we now have options to do downloads. We can do uploads. We can go online. We can compare different projects with each other. If you go here, you will find sample projects that you can use. So you can not only find documentation, but also ready-to-use Visual Studio projects that you can download, see how things are being done, and try to develop something of your own. So going back to the thing that I showed you before, I guess we can have a peek inside now and just open this project. So this project, well, we have a more basic project, and maybe I should actually show the more basic project. It makes slightly more sense. So if we go desktop, we go Openness V16, have this project available as well. And this is like one of the first demos that we have. And this demo is slightly better because rather than doing everything for you, it actually allows us to execute commands one by one. So if we go and look here, this is how it looks like. Okay, so what we can do is we can do all these different operations manually one by one. So we can first launch TI, attach to TI, and well, let's actually do it. Let's start this. So first thing we can do, but here it's already running. Let me close TI. And first thing we can do, we can launch TI. We press launch TI. How does it work? It just executes an easy command, says new TI portal, and I want it in a mode where it uses user interface. So it's very simple commands that we just use throughout, and they all come from the Siemens Engineering DLLs. The DLL files can actually be found in the installation folder. So if you go to program files, if you go to Siemens automation portal that you're using, and then we go public API, this is where you can find DLLs. So for version 16, the DLLs are available here. So as you can see, again, the firewall asks us if we can modify things. We say yes, and we have successfully launched TIA. Now, because we launched it, we already attached to the instance. If TIA was running, we might need to actually attach to the instance manually. And again, we have another command that just allows us to get all the running processes and attach to the process that we want to attach. Then we can do things like opening projects, creating projects. So let's say I want to create a new project, yeah? So I create a new project, Tech Talks 2, I guess, yeah? And we put this on the desktop in Tech Talks 2, okay. And again, this is another quite simple command. So if you look here, creating a project, well, there's a bit more code because it actually starts up the dialog window where it asks us for the name and where to put it. But the actual creation of the project is here. So tiportal.projects.create, we give it the path, we give it the project name. That's all that we actually do on the openness side. Then the project is created. We can start maybe adding PLCs. So to add the PLC, again, we have another command where we just say ti project.devices create with item. We give the type identifier, which is the not the serial number, the article number, and the firmware. We give it the name, and we give it the device name, and it's gonna add us a PLC here. And it's the same deal with all the other operations that we have available. So there are very simple commands that are well documented, and they just tell you, what you can do and which commands to use for different things. So as you can see here in our example, we can also do things like compiling software, exporting, importing blocks from XML files, inserting TOs, inserting drives, changing parameters of the drives, telegrams. We can download, go online, offline, compare, upload. So there are quite a lot of operations that you can do. And then there's a question, how to know what's actually possible. Like someone asked me, is it possible to change a certain property of a certain module? So there's no hard and fast rule on what you can actually do. Like as I said, most things are implemented, but not all of them. Some things maybe are just read, and the others you can read and write to. So maybe you can't modify some things. Maybe you can just read the status. There's actually something very handy, again, available on the support side. If you go to the support side and you just look for Openness Explorer. Openness Explorer is a little app. It's a tool that allows me to look at any project from the openness perspective, showing all the attributes that the Openness API can actually access. So you can just download it here. Again, you need to be a registered user of the support site. Well, if you're not, I would strongly encourage you to create yourself an account anyway. But then, if we just extract Openness Explorer, we fire up the exe file. It then allows us to select the DLL that we are using. So because I'm using the v16 DLL, I need to tell it, yeah, that's the version of TI that I want you to connect to. So port of v16, public API, v16, engineering DLL. Then refresh the list of TI instances running. As you can see, this one is running with the UI, with the user interface. We're going to start the Openness Explorer now. And this will show us the exact structure that the API actually sees and can access, and that's the structure that we need to be using when we create our own programs. Again, we need to authorize access, and there you go. That's a hierarchy tree where we can see that, okay, at the highest level, we have the TI portal, then we have the project running on the TI portal, then we have our devices, so our 1500, with loads of different parameters. And then when we go down, we have rail and actual POC. Yeah. And then we are going to find, things like POC itself. We're going to find the OPC UA because it's another service that's actually running on the POC. We will find the Profinet interface. So you can start going down and down this tree and exploring all different options and functions, and these are things that you don't normally think when you engineer with TI portal, but all these are available via Openness, and these are the things that you can do. And as you can see, Openness tells you which things you can just read, so check the status of maybe, and which things you can change. So you remember, like we said, if you want OPC UA server enabled, all we needed to do is set OPC UA server to true, and we could have done it because we have read and write access, and we could have done the same. Maybe set it as an OPC UA client, for example. So very, very handy up the Openness Explorer. But I don't want to stay with Openness. We are slowly running out of time. I still want to just quickly show you TI add-ins and SiVarc. Okay, so let's start with SiVarc. For this, let's quickly go to the project that we created previously. So the Tech Talks project, let's fire it up. Okay, so we have the project that we created previously, and if you remember, last time when I was mentioning SiVarc, I kept mentioning the SiVarc Rules. So where the SiVarc Rules actually sit is this common data area, and there you have SiVarc with all different rules that basically specify what things get copied from where. So one of the screen rules that we have is a screen rule that gets triggered by drive control TO. So drive control TO, if you remember the project, it's a block that sits here. And this block is automatically generated by Openness. So whenever Openness generates V of these drive control TO blocks, this will just look for different instances of them. So if we go back to drives, we have 3 instances of drive control TOs. And these instances will be triggers for this rule. So this will be triggered 3 times. What it's gonna do, it's gonna take this screen object, FP drive, and FP drive is a faceplate drive. It's the faceplate that you saw on the drive screen. It sits in the project library. And can we just edit it by us? But this is just a faceplate with its interface that gets them connected to different fields on the faceplate. So the existence of drive control TO instance triggers a creation of this faceplate FP drive. This faceplate is then put on a screen called drive in a place called faceplate. Where is this place? So if you go back to our screen, so we go back to the HMI, we go to screens, we go to drives, so that's our screen. Currently, as you can see, there is nothing, or at least there seems to be nothing. But if we go to plugins, we go and expand all these things. You can scroll down in the layout. You have this tick box. If you select the tick box to show layout fields, you can see that we now have 2 layout fields called faceplate and 2 layout fields called button. So basically what's going to happen based on our rule is if there is, what was it called? If there is a drive control TO block, it creates a faceplate from our library, puts it here in a place called faceplate, and tags it up to this drive control TO. If there is 2, it will put it here. But as you can see, only 2 fit on the screen. So if there is more, it just starts creating us new drives and then starts adding us buttons in place called button. That's in general and a very quick overview how the SiVarc rules work. By no means this is a step-by-step on how to do it. Unfortunately, we don't have enough time to do it today. But if you want to learn more about SiVarc, again, if you fire up your web browser, if you go to the support side, and if you just look for SiVarc itself, you'll find an application example, SiVarc Semantic Visualization Architect Getting Started. So really nice application example with documentation, where example projects explained. So you can just download yourself the example project and go through the documentation to understand exactly how to set up these things, how they work, and how they can work together with openness as well. So that's just a quick overview on SiVarc. The last thing that I mentioned, and it's a thing that wasn't actually used in my demo, are the add-ins. And again, if you want to know what the add-ins are, let's start by going back to our support side. Maybe I shouldn't have closed this, but okay. So I go to the support side and we just type TIA add-ins. Let's just flip the language as well to English. And there you go, TIA portal add-ins. So the add-ins give you the opportunity to expand the functionality of TIA. With the installation of TIA Openness, you have the possibility to use add-ins. They offer a convenient way to expand the functionality of TIA via Openness API. They are written as .NET programs, and they can be conveniently passed on in a company or even distributed to third-party providers. So what it basically means is you can write your own add-ins in things like C# using Visual Studio, for example. The add-ins use openness, but they are not external openness apps. They are openness apps embedded in your running instance of TIA that can be executed from within TIA, depending on the selections you make. So you maybe right-click on a POC, it does something. If you right-click on a function block, it does something else, and so on and so on. If you scroll down here, you can find some advantages of the add-ins. So they integrate seamlessly into TIA. They can be run without knowledge of higher programming languages. So while maybe I can, write an add-in, you, as a user of the add-in, you don't need to know anything about C#. You can just use it. They are context sensitive, and this is what I meant, that they can be doing different things depending on what you click. Maybe if I click a function, it's going to do something else. If I click a function block, it's going to execute a different action. If I click a POC, there won't be any choice at all, because maybe my add-in just can't do anything reasonable with a POC. They can also perform Windows system functions, so they can actually be started by TIA internally, but they can link to other applications running outside. Maybe, I don't know, send a file somewhere, grab a file, interact with other applications. And one of the others that we have actually does it. It's a Git add-in. If you then keep scrolling, you'll find some examples. So you'll find TIA portal add-in template. That's for any of you that might want to create your own add-in. That's like the example how you should structure your add-in internally in terms of programming it. Then you have 2 examples, FCFB converter and VCI git connector. And these examples, what you get from SiVarc, you get not only the exe file or the add-in file, but you also get the source code in Visual Studio projects. You can see exactly how they were programmed. So let's quickly start by me showing you the FCFB converter as an example what an add-in could be doing. The add-in can do anything you'd like. Again, it's just using openness, but this is an example of what the add-in could be doing. So let's download it quickly. Let's log in. This should be the one. Okay, so we log in quickly, this download it, then we can extract our add-in. Yeah, so the add-in was now extracted. What we can find inside is you can find the operating instructions in English and German. You can find the add-in itself, and you can find the install instructions. The manual itself, it just tells you what the add-in does, how to use the add-in. The install instructions, they tell you how to install the add-in. And installing the add-ins is amazingly easy. So if we go back to TI, oh wait, I actually might have an add-in running already. But okay, so let's just follow this. So let's go to display. Let's copy the add-in. Let's go to this PC. Let's go to C, to program files, to Siemens, automation, Portal v16, add-ins. Let's delete the add-ins that I already have. Sorry about this. Let's go back to TIA, to our project here. Okay. Now on the right hand side, what appeared with v16 is this add-ins. And as you can see, there's a list of all the add-ins that we have installed, but I currently have none. So I go back to my add-ins folder. I install the add-in by just pasting it here. And as you can see, the add-in immediately appears here on the right hand side. So you don't even have to restart your TIA. But this add-in has an X, which means it's not active. If you expand this, you can have an option to, you can see an option to activate this add-in. So we say, yeah, activate. Again, the TI firewall, if you will, gets triggered and asks us to give this add-in permissions to actually modify the code. We say, yeah, we know this add-in, we are happy with running this. And the FCFB converter add-in, if you read through the manual that is part of the download, you will find exactly what it can do. But in general, as you can imagine from the name, the FCFB converter add-in allows us to convert FCs, so functions, to function blocks, and vice versa. Because if you've used TIA a bit, you will know probably that if you have a function, you programmed everything, but then you think, oh no, I actually need some static values. So static values are not part of the function because function doesn't have any persistent memory. So for this, you need a function block with its instance DB. So let me show you how it would work. Let's say I have a function with my function. This my function. Yeah, and let's say I make a happy program, very complex one with an in and an out. Yeah. So all this is gonna do is a very simple logic. Yeah, and I'm happy with this. But then I realized, you know what? I actually would like to grab the status of this and like save it for whatever reason. So for this to save something permanently, I would need a static, but I don't have any statics in functions. So I would normally need to create a function block and copy things over. If it's a bigger program, it might be just slightly annoying. And the add-ins are designed to exactly, fix exactly this problem, fix the small annoying things. It wouldn't take me an awful lot of time. It's not a major deal, but it's something that, well, maybe it would be nice to have, the nice to have, the small actions in TIA that you keep repeating and can actually be automated. So this guy actually allows me to fix it. If I right click, you can now see that we have this new menu, add-ins, and FCFB converter is the add-in that we installed. Currently it doesn't allow, it just allows me to go into settings, but as you see, if I trigger it again, it now knows, okay, this guy is here, and do you want me to convert it to FB? In settings, you can find some settings for the add-in. So if it was a function block, for example, it would have statics. Then there's a question, what do I do with these statics? Do I remove them? Do I make them temps, in-outs? You can just set it here. If it's an FC, it returns a value. So what do I do with it? Do I just add an output to return this value? Or do I just completely remove the return? So it's very simple configuration. And again, this is just a sample of what could be done with add-in. It's a very basic one. So let's say I want to convert it to function block, and let's see what happens. So it closed it. It exported it using semantic ML, then it re-imported it using semantic ML to a function block. And now I have in, out, and static area ready for me. So again, a very simple example of what can be done, how actions can be automated in TIA. And if you go back to the science article, you will find more examples. You also find the VCI Git connector add-in. That's a really, really good add-in. Not sure if you heard about VCI, so version control in TIA. And we don't have that much time to explain this now. But what appeared as well with V16 is this version control interface, which allows you to use things like Git or SVN, so more the IT style tools for version control. To just version control, let's say, your POC, your function blocks mainly, and so on and so on. And what this, and then, for example, use things like GitHub, GitLab. And what this add-in can do, the add-in can actually drive the Git clients from inside TIA. So as soon as I make some changes to a block in TIA, I actually synchronize within TIA. So I say synchronize here, right-click synchronize. It can synchronize it to my local repository, but then also trigger an action that will actually push this update to my central repository. So that's a really good add-in. And again, you have a Visual Studio project to go with it. There are more add-ins available for these guys lower here. Unfortunately, you don't get the source code. But since we are talking about visualization, you might be interested in this, for example. So this is data to unified add-in. And it's a version 1 of the add-in that will get more development, but currently it can already export some data, so migrate some data from comfort panels, from runtime advanced to unified panels and unified advanced. For now, it's just HMI tags, except utilises and HMI lamps, but we are looking forward to get future releases of this that will be able to actually migrate even more for you. So that's just a quick flavor of what the add-ins could do, quick flavor of what SiVarc can do and what Openness can do. And I hope you like it. I hope you can see some applications of it. And if you have any questions at all, well, this is the time to ask.